right, chemistry students, so we are now going to be talking about the mole. So we're going to be moving into a very quantitative area of science in which there's going to be a lot of calculating, math, converting, learning how to figure out how much we have in a compound, and being able to supplement that later into chemical reactions, which we call stoichiometric calculations. So this chapter and the next chapter, be ready. There's going to be a whole lot of math that we're going to be focused on, okay? All right, so let's get right to it. So we're going to be talking about the mole, all right? And it is not an animal, even though we kind of joke about it and we put the animal mole in there. The mole is actually a unit used to measure the amount of something. So when we talk about the mole, we're referring to elements on the periodic table. So 1 mole of copper is going to equal the atomic mass of copper, and 1 mole of carbon is going to equal the atomic mass of carbon. Now, that name should sound familiar, atomic mass. Atomic mass was that average atomic mass that we talked about in first semester, where it's the little decimal number underneath the element symbol on the periodic table. So that is what we're talking about when we say 1 mole. That's equivalent to 1 mole of copper is going to be equivalent to the atomic mass of copper. Now, so 1 mole doesn't necessarily mean equal the same thing numerically, because it depends upon the element in which you're referencing, okay? So 1 mole of copper is not going to equal the same number of grams as 1 mole of carbon, okay? So just understand that's not an equal value, like 1 meter is always going to be 100 centimeters. That's not the same thing, okay? So I want you guys to be aware of that. 1 mole is the amount of a substance that we're referring to, okay? All right, so when we think about the mole, it's easy to look at things in terms of English standard units, okay? So think about a dozen eggs, right? So a dozen is a specified number, so it's 12 things, right? So if I say I have a dozen eggs, I have 12 eggs. If I have a dozen donuts, I have 12 donuts, so on and so on. So it's a number assigned to a unit. All right? Now, what about atoms? Atoms are a little bit different, okay? When we're looking at atoms, so chemistry is a quantitative science. We need a counting unit. We need to use something that we count with, okay? So with the mole, all right, it is the amount of substance that contains as many particles, atoms or molecules, as there are in 12 grams of carbon-12. So carbon-12 was our base unit when they started developing this method of counting. So they always reference back to carbon-12 because that's what they used as the standard when they started using this measurement. Okay? So look at counting atoms. So number. So 1 carbon atom is equal to 12 atomic mass units. All right? So the number is 1. Carbon-12 over 1 AMU is 12 over 1. So now if I have 2 carbon atoms, I have a mass of 24, okay? So I have 12 over 1. So the mass ratio to hydrogen, okay? Same thing here, okay? Mass ratio is 12 to 1. Mass ratio is 12 to 1. So what we're saying is we're comparing the mass of carbon to the mass of hydrogen, okay? So when you do that, it's going to be a 12 to 1 ratio, and that's where we got this base unit of carbon-12. So it doesn't matter what we use as we move down the periodic table, whether we're talking about multiple carbon atoms and multiple hydrogen atoms, it's always going to be the same, okay? So let's go and walk through the grocery store, and let's look at this in terms of apples, all right? So apples can be measured in 3 different ways. So at a fruit stand, they are often sold by the count. So if you go to Holland Bottom and you buy apples, they're going to say this much money for however many apples, okay? So they're doing by a number of apples at a fruit stand. Then you go to the supermarket, okay? You're typically going to buy apples by the weight or mass, right? You're going to put them on a scale, or sometimes they're sold in a bag. A lot of times you'll put a bunch of apples, right, in a bag, and you'll set it on that little scale when you check out, and it'll tell you how much you owe per mass or weight of apples, okay? Then if you go to an orchard, okay, an orchard and you pick your own apples off the trees. In an orchard, they're going to charge you by the bushel or volume. Okay, so a bushel is by the volume. So you're going to get a bucket, and they're going to say, okay, when you fill this bucket, that's going to be worth, so it's so much per bucket. If you go and pick blueberries, same thing. They're going to give you a container or a bucket and say, okay, it's this much per blueberries. All right, so when you're picking them yourself or you're at a farm, they're going to go by volume. Now, each of these different ways to measure apples can be equated to a dozen apples. So if you're doing it by count, a dozen apples are equal to 12 apples. All right, for average size apples, the following approximations can be used. So by mass, a dozen apples are equivalent to 2 kilograms of apples. By volume, a dozen apples are also equal to 0.2 bushel of apples. All right, so keep this in mind because now we're going to do some converting. So here's our ratio. So we know that a dozen apples are equal to 12. That's our first conversion ratio. Then we know a dozen apples also equal 2 kilograms of apples. That's our second conversion. And then we also know that a dozen apples are equivalent to 0.2 bushels of apples. That's our third conversion. All right, so knowing how the count, mass, and volume of an item relate to a common unit allows you to convert among these units. For example, based on the unit relationship, you could calculate the mass of a bushel of apples or the mass of 90 average size apples using conversion factors such as the following. So a dozen apples over 12 apples, 2 kilograms over a dozen apples, and 1 dozen apples over 0.2 bushel of apples. So there's your 3 ratios, 3 conversion units. Okay, so let's try to convert this. So what is the mass of 90 average size apples if 1 dozen apples has a mass of 2 kilograms? Okay, so they're looking for 90. So we know the number of apples are 90 apples. We know that there's 12 apples in a dozen, and we know that a dozen apples equals 2 kilograms. So what we're looking for is how many kilograms are those 90 apples. So let's set it up in a conversion. Remember, you always start a conversion with the number they give you in the problem. So the number they were talking about is we have 90 apples, and we want to know the mass of those 90 apples. So we start out with 90 apples, and you can either leave it like that or you can put it 90 over 1 to keep it in a ratio format. Okay, now I need apples to cancel out. So I go back to my 3 conversions that I had, and let me see. Okay, so in my conversion, it told me that for a dozen, I have 12 apples because I want the unit of apples to cancel out first. Whatever unit that you have here, that is the first unit you want to cancel out. And remember, we've talked about this. If you want a unit to cancel out, they must be diagonal in the ratio. So I'm going to put 12 apples here. What is equivalent to 12 apples? 1 dozen. Okay? So now the apples will cancel out, but I'm not looking for a dozen, I'm looking for the mass. So then I go back to my conversion chart. So I need a dozen to cancel out, dozen apples to cancel out, and I'm looking for mass. So I go to my conversion, I say, okay, 1 dozen apples are equivalent to 2 kilograms of apples. So now my dozens cancel out. Never cross out the numbers, only cross out the units, because you start crossing out the numbers and then you're going to get confused. Now, there's 2 ways to do this. You can multiply by ratios by putting parentheses in your calculator. So you could say 90 times 1 over 12 times 2 over 1, right? Or some people prefer to multiply everything on top, multiply everything on the bottom, and then divide. It doesn't matter, okay? What does matter is if you do multiply by the ratio format, you need to make sure you put each ratio in parentheses in your calculator. So 90 times parentheses 1 over 12 times parentheses 2 over 1, okay? And then that will give you 15 kilograms of apples. I would suggest testing that out to make sure you're doing it correctly. Now, here's where we're going to move into talking about particles, okay? So chemists need a convenient method for accurately counting the number of atoms, molecules, or formula units of a substance. The mole is the SI unit or base unit used to measure the amount of a substance, which is what we've been talking about. So The mole is the amount of atoms in 12 grams of pure carbon. Oh, there's that pure carbon again. Remember, that was our base that we based everything off of when we started talking about the mole. Now, 6.02 atoms, 6.02, excuse me, times 10 to the 23rd atoms. There was a man by the name of Amadeo Avogadro. He's the one that started talking about counting atoms, counting particles. Now, you have to remember, an atom is smaller than a mole, okay? So you have 12 grams of carbon when you have 1 mole. You have 6.02 times 10 to the 23rd atoms when you're talking about a particular atom of carbon, okay? So atoms are much smaller unit than grams, okay? So you need to remember that. So the number is called Avogadro's number after the man who originally developed the number. This is Amadeo Avogadro, okay? Okay? He was born in 1766 and died in 1856. He never knew his own number. It was named in his honor by a French scientist in 1909. Its value was first estimated by Joseph Loschmitz, an Austrian chemistry teacher, in 1895. So, basically, this is the actual number that he came up with, which we abbreviate or put into scientific notation. So 6.022 times 10 to the 23rd, there is Avogadro's number of particles in a mole of any substance. So when we talk about the mole, and we're looking at individual atoms or molecules, okay, we're using this number, or we even use formula units or particles or anything like that, any kind of terminology like that. That's going to be equivalent to 6.02 times 10 to the 23rd power. And that's what we're going to be focusing on today. So a computer counting 10 million atoms every second would need to count for 2 billion years to count just a single mole. So think about that. So X number of seconds equals 1 year, right? So there's 365 days in a year. There's 24 hours in a day. There's 60 minutes in an hour and 60 seconds in a minute. That's equivalent to 31,536 or 31 billion years. Okay? Or seconds, excuse me. All right? Now, therefore, 1 year has 31 million seconds, or 3.1 times 10 to the 7 seconds. A computer counting 10,000 atoms every second could count 3.153 times 10 to the 14 atoms every year. Okay, we're talking about a computer. So finally, 6.02 times 10 to the 23rd atoms divided by 3.1536 times 10 to the 14 atoms every year equals 1.9, right? 0.929,477 years, or approximately 2 billion years. Okay? I did not come up with that number. I just found it. But I find that very interesting. Okay? So, how big really is a mole? So, 1 mole of marbles would cover the entire Earth, oceans included, for a depth of 3 miles. That's how big a mole is. 1 mole of $100 bills stacked one on top of another would reach from the sun to Pluto and back 7.5 million times. It would take 9,500 years to travel from the bottom to the top of a stack of 1 mole of $1 bills. So, when you ask how big is a mole, that is how big is a mole. Okay? So, let's talk a little bit more about moles of particles, right? So 1 mole of glucose. Now, glucose molecules. A lot of people often are confused when I use the term molecules versus atoms. Atoms is a singular element, okay? So when we talk about 1 mole of sulfur, we're going to say 1 mole of sulfur, is equal to 6.02 times 10 to the 23rd atoms of sulfur. But if we say I have 1 mole of glucose, glucose is table sugar, that's going to equal 6.0 times 10 to the 6.02 times 10 to the 23rd molecules of glucose. because glucose is a compound. It has more than one element. So when we're talking about a compound or formula, we can't use the term atoms. We have to use the term molecules. But if we're talking about a single element such as sulfur or carbon or hydrogen or any of these elements, that's when we can use the term atoms. So the difference between a molecule and an atom has to do with the number of elements. A singular element is an atom. More than one element is a compound, which we could call a molecule or a formula unit. So basically, molecule or formula unit